a pipe open at both ends has a fundamental frequency f in the air, the pipe is dipped vertically in the water so that half of it is in water, the fundamental frequency of the air column is now. So in this case, it is basically a concept of open and closed pipe. Open means open at both ends when it is in air, and the other case will be closed end, means one end is open and other end will be closed because half of it is submerged in water. So we start with that when the pipe is open at both ends, its fundamental frequency is determined by the fact there are antinodes at both ends because it is open. Determined by the fact that there are antinodes at both ends. So in that case, we can say that the wavelength of fundamental node lambda will be equal to 2 multiplied by L, and the fundamental frequency, or we can say the frequency of fundamental node f will be equal to v upon lambda, and this gives us v upon 2L. Here v is the speed of sound in air and L is the length of the pipe. V is the speed of sound in air and L is the length of the pipe. Now in the question it is given that half of the pipe is submerged in water. Half pipe is submerged in water. So it means that only the air column above the verb, now you can say the air column that will present will constitute only the half of the length of the pipe. So we can say therefore the air column above water forms new effective length. And we can write that this L effective will be equal to original length divided by 2. This happens because as the water now acts as a boundary wall. Water now acts as a boundary which results in a node. Which results in a node. So we can summarize this thing that now our pipe is open at one end and closed at other end. So you can say that for a pipe open at one end and closed at other, the fundamental node will be because of the surface and the antinode at the open end. So we can say the fundamental mode has a node at the water surface and antinode at the open end. So we can write the formula that the wavelength of the fundamental mode fundamental mode that is our lambda will be 4 times multiplied by our lambda effective, and which is 4 times our L by 2, L effective, not lambda effective. L effective, which is, and this comes equal to 2L. Therefore, new frequency let us call that F new will be equal to excuse please, V upon lambda, and lambda we just calculated. Let us call this lambda prime. Lambda prime is equal to V upon 2L, and we can write this as V upon L, and this V upon L is nothing but our F. So we get our F new will be equal to F upon 2. So the new frequency becomes half that of the original frequency, and the options that are available to us, we can say option number A is the correct option. Option A is correct. So this completes the question. Thank you.